In this session, we will continue with the project we started last time. The digital input pin we used last time was the PC3 pin. If we check the PC3 pin again, in the input section, you will see that it indicates floating, WPU, plug, and whether it has an external interrupt. In the case of PC3, it is currently marked as interrupt capable. I mentioned PC3, but we need to confirm one more thing. On page 43 of the interrupt vector mapping, you will see that the port's external interrupt has an interrupt number of 5. Remember this number, 5, as you will use it later when coding. You need to keep in mind that port C is 5. Following this, we will be utilizing specifically the external interrupt-related files, and in the libraries folder, you will locate the file stm8s.xti, which is a crucial component related to interrupts, ensuring proper functionality. You need to include this to the make file, which is a critical step. So, when you open the make file in the lib folder, you will clearly observe the actual C files we are using added here, but you should ensure the removal of any files that you are not using. Suggestions that are widely acknowledged to definitely exist and are generally accepted. This is just what is currently in the source folder. I have added it now. At this moment, I can see that our task is to add this element here. By doing this, we ensure the make file is ready for use. This step is crucial as it finalizes the setup, ensuring everything is in place for the next stages. Next, since we will use the pin as it is important to keep this macro constant to ensure stability and maintain the current configuration. Simply add 1 xt above it, which is a necessary step to enhance functionality. After that, the pin settings will change, allowing for improved performance and adaptability in various scenarios. Here, the pull-up is absolutely correct, but instead of no interruption, it is an interruption. So, set this up as a pull-up with an interruption in this particular scenario. This operation is identical to the one from the last session physically, in terms of physical operation. Therefore, if the button is not depressed, the LED will be off, and when the button is depressed, the LED will illuminate. We will manage this not with the digital read command we used last time, but with interruptions. First, please turn off the preliminary configurations here, and then we will go into the settings related to interruptions. Since it is T, 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 C, C port, then XTI, DBT, we will put one of these in. If you look at the macro level constants here, it seems there is an enumeration instead of a macro constant. If you look at this, you will see options like fall, low, rise only, fall only, and rise fall. So you can adjust it to match what you want, whether it's going from high to low or low to high. However, in this session, we need to observe both transitions, so I will set it to nice fall. It was a pleasant autumn day when the leaves were falling gracefully from the trees. Suddenly, without any warning, the label that was attached to the branch unexpectedly dropped down to the ground. Please set the drops, but honestly, this is not necessary. Just leave it empty. Next, the function void PC. IRQ void is brought up in the discussion. It is crucial to note that the name of this function is not important, but it is important to write interrupt afterwards. Furthermore, it is essential to ensure that you could. Please check the XTI again. Here is the vector corresponding to port C, and the interrupt number is 5, so you just need to write down this number 5 correctly. The name in front doesn't matter. However, later on, just to distinguish it from port A, port B, and port C, I have now gotten into the habit of calling it the PCIRQ handler. Then you can simply just write this code right here in this particular section. Because this executes when it goes from high to low and from low to high, we need to read whether it is actually high or low. So you can absolutely and indeed put this in, or perhaps it would actually be better to put this one in. Again. Once again, here we changed the pin settings from no interrupt to interrupt last time. And we set up the interrupt related configurations. We activated the interrupt with a rise fall. And I have now declared the function that will be executed when the interrupt is triggered. I will build this and try to implement it. It has been built, and as you may recall, the operation is the same as last time. When it is off, it does not turn on, and when it is on, it triggers low, high, and rise, which are detected and cause changes. When released, it triggers fall, and high is detected, leading to changes. If you want to use another pin as an interrupt, check the pin map to see if it can be used as an interrupt. If you decide to use PD6 for the interrupt, as we saw earlier, since it is port D, port corresponds to pin 6. Then it's number 6. For instance, you have the option to approach it in this manner. Begin by setting up the initial framework, and then proceed to input the specific content that you wish to include. This method allows for flexibility and customization, ensuring that the final result aligns with your particular needs and preferences. This time, I explained how to control the interrupt in SM8. I will return with another topic.